Hello students, welcome back. Let's go to section 3, inequalities. Section 2 was really hard. Section 3 is not going to be too bad. Basically, the linear inequality uses this property. If you multiply a positive number to an inequality, no change. The inequality is preserved. If you multiply a negative number, then you have to flip the inequality. That's basically it. How do you handle this kind of problem? Well, the standard process is denominator, parentheses, and like terms. We don't have denominator, we don't have parentheses either. We just have like terms. So let's go ahead and do that. Let's flip this 8x to the other side. 3x minus 8x, so negative 5x. And then 15 was there before. Flip the 7 to the other side. So 15 plus 7, it is. 15 plus 7, what is it? 22. And then divide by negative 5. And that's how you can handle it. Or you can do it like this. Let's see. We have 8x here, 3x there. So if I flip the 3x to the right-hand side, then I won't have to meddle with multiplying by or dividing by negative number. So let's go ahead and do that. Flip this 15 to the other side. Negative 7 minus 15, that's minus 22. Now we have 8x here, and then subtract 3x, so it's 5x. And then divide by 5. Negative 22, divide by 5. Either way, we got the same thing. Which method do you prefer? I prefer the second method, as a matter of fact, because whenever I deal with negative numbers, I cannot think straight. Actually, I used to make a lot of stupid computation mistakes, really stupid computation mistakes a lot when I was in high school, and all the problems there were multiple choice. So no matter how small a mistake is, you just get 0 credit. Terribly unfair, but that was the nature in high school. So what choice do I have? I had to protect myself from making mistakes, and one of the things that I created, one of the methods I created for myself is to avoid negative. So this is one of them. Oh, here, okay, all right. We got the solution, but we can express it in the interval notation as well. Okay, all right. Interval notation, okay, all right. Greater than or equal to negative 22 over 5, so to the right. And greater than or equal to, so this is bracket, equality is included. How about this? We have parentheses, so okay. Let's work something out. 4 plus 3x, that's okay. And then let's break up this parenthesis. Negative 3 times 3, minus 9. And then negative 3 times negative 2x, that is positive 6x. Are you with me here? Always be careful when you break off parentheses, especially with the negative sign. Negative sign is a part of the next number. It's not a subtraction because subtraction does not exist. Everything is addition, just adding a negative number. So whenever you see a negative, it's part of the next number. Same goes here. Negative 3 times negative 2x, that's what you're doing, and you get positive 6x. Right hand side, x plus 11 was there before. Let's break up this. Negative 2 times 3, so negative 6. And then negative 2 times 2 is negative 4x. Okay. And then let's take like terms together. 3x, 9x, and then Oh, never mind. All the hard part is now done. Taking the like terms together and completing the problem, I'm going to leave to you. Stop the playback and go ahead. If you have difficulty, you can always look up the answer key. And let's go ahead and do that. Basically, we are up to here after breaking of all the parentheses. And then take the like terms together, we get this. And then flip this 3x to the left-hand side, we get this and eventually 12x. And flip this -5 to the other side, we get this and eventually 10. So x is greater than 10/12 or greater than 5/6. Greater than 5/6, so in the interval notation, to the right-hand side of 5/6, so 5/6 to infinity. Okay, here's another problem. This time we have denominator as well. We have denominator, so bigger font is going to be more appreciated. What do you do here? We multiply the same thing to each term and then kill off all the denominator. That's what we want. And that something, of course, will be a positive number, so I don't really have to meddle with change of direction here. Let's put some space in between. And we have denominators 3, 6, and 4. So what is the LCD? "12" is the best choice. I see many students making this mistake of leaving 1 as alone, but no. We're using the distributive property. Multiply 12 to both left-hand side and right-hand side. But by the distributivity, it has to be distributed to each term. So 1 times 12, that should stay. Let's finish the computation. What was the purpose of all this? What was the step 1 of all this? Denominator, parentheses, and like terms. So denominator first. Do not break the parentheses yet. That's step 2. You have to complete step 1 first. Denominator first. Divide by 3. 12 over 3 is 4. Next, 12 over 6 is 2. 1 times 12 is 12. 12 over 4 is 3. So here we go. We got the equation, same equation, now no denominator, just parentheses. So step 1 is done. Denominator, parentheses, like terms. That's the process. Step 1 is done. Step 2, parentheses. Okay, let's break up the parentheses. 4 times 3, that's 12. 4 times x, that's 4x. And then, how about this? -2 times 6. -2 times 1. -12. And then -3 times 8. -3 times -1. Are you with me here? Be careful about the signs. And then, okay, you can take the like terms together and complete the problem. All the hard part is done. Denominator, check. Parentheses, check. We only have like terms. Stop the playback and complete the problem on your own. You should be able to do it. Let's see, what do we have here? We are up to here. Yeah, we are up to here. And then take the like terms together, simplify further, and you're gonna get greater than 5/6, greater than or equal to 5/16. So we have closed interval 5/16 to infinity. Okay, alright, let's go back to the normal font size. How about the next batch of problem sets? Okay, Here are some new problems. What if we have double inequalities like this? No big deal, the same deal. Denominator, parentheses, like terms. Denominator first, so let's multiply the same thing to each term. What do I multiply? Multiply by 2, of course. So multiply by 2, and that's gone, and multiply by 2. Any parentheses? No? So let's go ahead with the like term. We have only x here, so that's good. Remove 3 to the other side. So subtract 3 from each. So negative 2 minus 3, what do you get? Negative 5. Did I do this right? And then subtracting 3, this one goes away. Now 18 minus 3. Am I getting 15? Please check. Minus 3 from here, minus 3 from here, and minus 3 from there. Same deal. Denominator, parentheses, like term. No parentheses, so denominator, we kill it by multiplying 2 to each. And then, like term, we subtract 3 from each. And final division, divide by negative 5 from each. Negative 5 divided by negative 5, we have 1. And then negative 5, 15 divided by negative 5, so negative 3. Something doesn't look right. What mistake did I make? I divided by a negative number, right? So I have to flip the inequality. That's the mistake I made. So that's okay. That's good for what do you call that's good for inequality notation. But if you want interval notation, it's better to have smaller number in left hand side and then larger number in the right hand side, so that you get a little bit better transition like this. Do we have enough time for the second problem? I don't know. Let's try. I may have to speed up a little bit. Multiply by, what do I multiply? Multiply by 12, 3 times 4. So multiply by 12, multiply by 12, multiply by 12. So let me specify that. Okay, like this. And then we have to break up the parentheses. So minus 4, and then 9 minus 21x, 24. What do we have now? We have no more parentheses, just like terms. Flip 9 to the other side, and can we complete? Can we complete in time? Negative 4 minus 9, so we're going to get negative 13, negative 21x, and subtract 9, we get 15. Well, I guess I'd better stop here. Also, I'm no longer certain if my mental math is correct either, so I'll just stop here and let you finish. Hard part is all done. We only have like terms, so I'll let you finish this problem. And then I'll say section 3 is done. And we're going to talk about section 4 in a separate video.